Using a depth-first search traversal algorithm, we can detect cycles and derivative graph. If there is any subloop in any node, it will be considered as a cycle. Otherwise, when the child node has another edge to connect its parent, it will be considered also a cycle. In this approach, we will use different sets to assign nodes to perform the if-S traversal. There are three different sets: the white, gray, and black set. Initially, all nodes will be stored inside the white since it is unvisited yet. When one node is traversed, it will be stored in gray set and removed from the white set. And after completing the backtracking, when the task for that node is completed, it will be snapped from gray to black set. There are also flags to perform if-S traversal. -1 is the unvisited node, which stored in white set. 0 is visited node and transferred to gray set. 1 is visited and transferred to black set.
In this graph, we have 6 nodes. First, 0, 1, 2, 3, 4, and 5. And since these all nodes are unvisited, let us write this -1. Since the flag in -1 indicates unvisited. So now let us visit 0. So since we have visited 0, let's change this -1 to 0. Since 0 is visited and now stuck in the gray set. So let us pop out 0 from white set and now let's write it down to gray set. And let us not forget the parent map. So the vertex is 0. Since 0 has no parent node, so let us write this now because it has no parent node. And since we have visited 0, let us find its neighbor. So the neighbor of 0 is 1. So now let us visit 1. Since we have visited 1, let's change this -1 into 0 because 0 is visited. And let us pop out 1 from white set and then let's write it down to gray set. And let us not forget the parent map. So the vertex is 1 since we have visited 1. And then what is the neighbor of or the parent node of 1? It is 0. So let's write 0 as a parent node. Since we have visited 1, let's now find the neighbor of 1. So in this graph, 1 has no neighbor. So let's backtrack to 0. Since we have backtracked to 0, let's now change this 0 to 1. Since 1 is visited and now put into black set. So let us pop out 0 from gray set and then it will be right down to black set. After backtracking, let us choose another node. So I choose 2. Since we have visited 2, let's now change to 0. And now 2 will be right down into gray set and it will be popped out from white set. And let us not forget the parent map. So the vertex is 2. And what is the parent map or parent node of 2? It is 1. After visiting 2, let us now find the neighbor of 2, which is 3. So since we will visit 3, let's change this -1 into 0. And then 3 will be right down into gray set and it will be popped out from white set. So the vertex is 3 and the parent node of 3 is 2. And now let us proceed to the finding of the neighbor of 3, which is 4. Since we will visit 4, let's change this into 0. And since we have visited 4, let's pop out 4 from white set and then let's write it down to gray set. And the vertex is 4 since we just visited 4. So the parent node of 4 is 3. After visiting 4, let's find the neighbor of 4, and which is 5. So since we will visit 5, let's let's change these two into negative 1 to 0. So since we have visited 5, let's crush out 5 from white set and write it down to gray set. So the vertex is 5 since we just visited 5. And what is the neighbor of, or the parent node of 5? It is 4. After visiting 5, let's now visit the neighbor of 5, which is 2. But as you observed, 2 has been visited. So, and as you observed in this graph, each node has a corresponding flag of 0, which is visited. So we can detect now this cycle in this graph. So since we have reached to 5 and 2, let's write 5, 2, 2. And to detect the cycle, let's use the parent map. What is the parent of 5? It is 4. So let's write 4. So, in 4, the parent of this is 3. So let's write 3. So the parent map of, or the parent node of 3 is 2. So that's the use of parent map. So as you observe, 2 to 3, 3 to 4, and 4 to 5, and 5 to 2. So, this is now the cycle.
Since we already detect the cycle here in our graph from 2, 3, 4, 5, and 2, supposedly we will delete the edge from 5 to 2. And now, we will delete it. The question here, does 5 has a neighbor? So, since 5 doesn't neighbor anymore, so it will be located now in the gray set. And gray set also, as you observe that it have a flag of 0. So, since it's already visited now here in our set, so it will be transferred to the black set and it will be popped to the gray set. Since the flag is visited, it will be changed now into 1. And now, let's perform the backtracking. As you observe, we backtrack from 5 to 4. And now, we locate 4. Since we locate 4 and it will already visited and put it in the gray set, it will be popped. So, let us pop before. So, it will be transferred now into the black set. Since the rule now is to change the flag from 0 to 1. So, let's change now from 0 to 1 because it's already now visited. Now, let's go to backtracking. Since we already finished backtracking from 4 to 3, and now let's see where is 3 located. Since 3 is located into the gray set, which is already visited now in our graph, and now let's pop 3 and transfer to black set. And also, we will change the flag from 1. Another backtracking will be observed from 3 to 2. Since 3 and 2 have a backtracking, now gray set is now located 2. So since 2 is located in the gray set, so it already visited now in our graph, and it will be transferred now into the black set. And we will pop the gray set. And the volume or the flag of the 2 will be changed into 1. And it will change. And another thing is, last backtracking is the 2 and the 1. 2 and 1. So the final backtracking happens in 2 to 1. So 2 now had the neighbor of 1. And then 1 now is located in the gray set, which is already visited now in our graph. And 1 will be popped up to the gray set, and it will be transferred now into the black set. And after that, we will change the flag from its graph. It will change to 1. And now, this is the backtracking for the cycle detection using DFS.
Good day, everyone.
Hi, I'm Philip.
I'm Daniel,
I'm NJ.
and we are from Davao del Norte State College, taking the course of Bachelor of Science in Information Systems.
In this video, we will learn about the cycle detection in directed graph using the DFS.
Good day.
Good day, everyone.
Behind the scene.
To connect its parent, it will be considered as a sample. Sorry.